Consider your coffee cup. It sits on the table in front of you, ceramic, slightly chipped perhaps, filled with something that was hot 10 minutes ago. You know it's there. You can see it, touch it, drink from it. And when you leave the room, you know with absolute certainty that the cup remains on the table, patiently waiting for your return, existing whether you observe it or not. But here's the strange thing. How do you know? We take for granted that reality exists independently of our observation. Things are there, whether anyone looks at them or not. The moon doesn't disappear when no one gazes at it. Your kitchen continues to exist while you sleep. The universe carried on quite well for billions of years before any consciousness emerged to witness it. This assumption is so fundamental that questioning it feels almost mad. And yet, as we shall see, physics, the most precise science we possess, has slowly, reluctantly been forced toward a disturbing conclusion. The assumption may be wrong, not wrong in some trivial philosophical sense, wrong in the way that matters most. When we actually examine reality at its deepest levels, we find something that refuses to conform to our expectations about observer-independent existence. Let me be clear about what we're questioning. Every sentence you speak embeds this assumption. The coffee is hot. The star exploded. The market crashed yesterday. Each statement presupposes a complete reality we're merely sampling, a cosmic ledger that records everything whether witnessed or not. We don't argue for this belief. We speak from within it. We breathe it like air. Why do we believe this so instinctively? The answer is evolution. Your ancestors who wondered whether the tiger was really there when they weren't looking at it were eaten by tigers. Natural selection built brains that model a stable external world because such brains survive better. The tiger doesn't disappear when you close your eyes, and your genes carry the message loud and clear. Believe in observer-independent reality or become lunch. This evolutionary inheritance served us magnificently for millions of years. It still does, for everyday purposes. But survival strategies aren't the same as metaphysical truths. Evolution built you to reproduce, not to understand the fundamental nature of existence. These goals occasionally align. Often they don't. For most of human history, physics seemed to vindicate our instincts entirely. Newton's laws describe a clockwork universe ticking away, regardless of observation. Maxwell's equations govern electromagnetic fields that propagate whether or not anyone measures them. Even Einstein's relativity, strange as it is, preserves the basic picture. Reality exists out there, independent and complete, and our observations merely sample it. Then came the 20th century, and everything changed. Imagine you leave a room containing a coffee cup. The door closes behind you. What is the cup doing right now? The naive answer comes instantly. It's sitting there, unchanged, waiting. But examine that answer. You picture the cup continuing its existence, same position, same temperature gradient, same ceramic solidity. That picture is in your mind, not in the room. You cannot verify it without opening the door, and the moment you open the door, you're observing again. You might object, but obviously the cup continues to exist. That's just common sense. And you'd be right that it's common sense. Common sense, however, is a collection of prejudices acquired by age 18. It evolved to track medium-sized objects at medium speeds over medium distances. It has no authority over the fundamental nature of reality. This isn't skepticism for its own sake. I'm not suggesting you should doubt whether your coffee cup exists when you leave the room. For practical purposes, of course it does. What I'm suggesting is far stranger, that the question, What is the cup really doing when no one observes it? May not have an answer. Not because we lack sufficient information, but because the question itself may be malformed, like asking what lies north of the North Pole. The philosopher Samuel Johnson famously kicked a stone to refute Bishop Berkeley's idealism, declaring, "I refute it thus." The stone was solid. Case closed. But Johnson lived before quantum mechanics. Today we know that the stone's solidity is a statistical average of countless quantum events. At the deepest level, the stone is not a thing, but a process, a pattern of probabilities that manifests as solidity only through interaction with other systems, including Johnson's foot. The interaction is part of the story. There may be no story without it. We find ourselves in a bewildering position. Creatures evolved to model a stable external world, now trying to understand whether that stability is reality or projection. The comedy of our situation should not be lost on us. We are monkeys who climbed down from trees and started wondering whether the moon exists when no one looks at it. Einstein found this so distasteful that he spent his final decades trying to prove quantum mechanics incomplete. "Do you really believe," he asked a colleague, "that the moon exists only when you look at it?" The honest answer, it turns out, is we cannot say. Not because the question is too hard, but because it may be the wrong kind of question entirely, a question whose grammar suggests it should have an answer, while the physics suggests otherwise. We have destabilized what you probably never thought to question: the assumption that reality exists independently of observation. But destabilizing assumptions is only useful if we can offer something better. Where do we go from here? If we cannot simply assume reality is out there, waiting to be discovered, what can we say about it? Is there any solid ground at all? The answer lies in an experiment so simple a child could describe it, yet so profound it shattered our picture of reality and forced physics to confront questions it had comfortably ignored for centuries. There is an experiment that can be performed on a tabletop with equipment costing less than your morning coffee. It requires only a light source, a barrier with two thin slits, and a screen to catch what comes through. A child can set it up in an afternoon. And yet this experiment, the double-slit experiment, has done more to demolish our intuitions about reality than any other discovery in the history of science. If you truly understand what it reveals, you will never see the world the same way again. Here is what happens. Fire particles, electrons, photons, atoms. It doesn't matter. At a barrier with two slits. On the other side, place a detector screen that records where each particle lands. Now watch the pattern emerge as thousands of particles accumulate. If particles were simply tiny bullets, you would expect two bands on the screen, one behind each slit. That's what you'd see if you threw tennis balls at a wall with two gaps in it. Some balls go through the left gap, some through the right, and you get two clusters. But that's not what you see. Instead, the particles create an interference pattern, alternating bands of high and low density, exactly like the pattern you get when two water waves overlap. It's the unmistakable signature of wave behavior. This is already strange. Particles acting like waves, but it gets stranger. Slow down the experiment. Fire particles one at a time, with long pauses between them. Each individual particle lands at a specific point on the screen. A particle-like behavior, but wait long enough. Let enough single particles accumulate, and the interference pattern emerges anyway. Think about what this means. A single particle, traveling alone with no other particles to interfere with, somehow knows to land in a place that will contribute to a wave pattern. A pattern that only becomes visible after many particles have landed. It's as though each particle interferes with itself, passing through both slits simultaneously and interfering on the way to the screen. But here is where things become truly bewildering. Set up a detector to observe which slit each particle passes through. You might expect this makes no difference. After all, you're just gathering additional information about what's already happening. But when you do this, when you measure which slit the particle traverses, the interference pattern vanishes completely. You get the two-band pattern you'd expect from classical bullets. The act of observation changes the outcome. This is not about clumsiness. You can design detectors so gentle they impart no momentum, transfer no energy, cause no classical disturbance whatsoever. It doesn't matter. The mere availability of which path information, even if you never look at it, destroys the interference. It's not about physical disturbance. It's about information. Let me be precise about what the experiment reveals. When we don't observe which slit the particle traverses, it behaves as though it passes through both slits, interfering with itself like a wave. When we do observe, it behaves as though it passes through only one slit, acting like a particle. The question, which slit did it really go through, has an answer only when we set up an experiment that determines one. Before measurement, the particle doesn't have a definite path we're merely ignorant of. It exists in what physicists call a superposition, a genuine, both at once, that only resolves into a specific outcome upon observation. This is deeply counterintuitive. Our instincts rebel against it. Surely the particle must be doing something when we're not looking. Surely it has some definite state. But every experiment we have devised, and we have been trying for a century, confirms the same result. The particle's behavior depends on the experimental arrangement. Ask a which path question. Get particle behavior. Don't ask. Get wave behavior. The question isn't revealing a pre-existing fact. It's participating in determining what becomes fact. Einstein hated this. God does not play dice, he famously declared. The response attributed to Niels Bohr, stop telling God what to do. But I would put it differently. Not only does God play dice, he sometimes throws them where they can't be seen. Now, you might think this is all very well for electrons and photons, tiny things in laboratories. What about the real world? What about coffee cups and moons? The curious answer is that quantum mechanics, in principle, applies to everything. There is no size limit in the equations. A coffee cup is made of atoms. Atoms are made of particles, and particles obey quantum rules. The reason your cup doesn't exhibit quantum interference isn't that the laws don't apply, it's that cups interact constantly with their environment. Air molecules, photons, the table beneath them. These interactions constitute measurements in the technical sense. The cup is being observed continuously by the universe around it, and this observation suppresses quantum superposition. This is called decoherence. It explains why quantum weirdness is hidden at human scales, but it doesn't explain it away. The weirdness is real. We've just learned to engineer around our incomprehension. Indeed, you use quantum mechanics every day. The device you're watching this on, its processor, relies on quantum tunneling. Medical imaging uses quantum spin. GPS satellites correct for quantum effects. The strangeness isn't locked away in laboratories. It's the foundation of the technology surrounding you. We've built a civilization on physics we don't fully understand. What then are we to conclude? The double-slit experiment forces us to abandon naive realism, the assumption that reality has definite properties whether observed or not. Before measurement, there is no fact about which slit. There may be no fact about anything definite. The question, what is really happening when no one looks, may be malformed, like asking what time it is on the sun. This is not mysticism. It is not New Age wishful thinking about consciousness creating reality. The role of consciousness in quantum mechanics remains deeply controversial, and I don't wish to overstate the case. What does the measuring needn't be a human mind. Any physical interaction that records information will do. A photon bouncing off a particle measures it just as surely as a scientist with a clipboard. The mystery isn't consciousness. The mystery is the role of information itself. We've seen that physics forces us to abandon naive realism, but abandoning an assumption leaves a void. If we can't simply say reality exists independently of observation, what can we say? Is there any solid ground at all? As we shall see, there is, but it's different ground than we expected. The answer is something called model-dependent realism, and it requires us to think very differently about what truth can mean. Imagine a goldfish living in a curved bowl. The fish swims, observes, and over generations develops intelligence enough to do physics. It watches objects moving outside the bowl through the curved glass. A ball rolling in a straight line outside appears, from inside, to move in a curved path. The glass distorts everything. The fish physicists develop equations describing this curved motion. They account for the distortion. Their physics becomes sophisticated, elegant, predictive. They can calculate exactly where any object will appear to go. Now here is the question. Is the fish's physics wrong? You might say yes. After all, the ball outside is really moving in a straight line. The fish's curved description is just an artifact of their distorted view. But consider more carefully. The fish's physics predicts every observation the fish can make. It is internally consistent. It passes every test the fish can devise. On what basis, then, would we say it's wrong? We might insist that we, outside the bowl, have access to reality as it truly is, undistorted, direct, unmediated. But do we? Our eyes are lenses. Our brains are interpreters. Our instruments are assumptions made physical. There is no observation that doesn't come through some framework. Perhaps we are all fish in curved bowls of one sort or another. This leads us to a position I call model-dependent realism. It is simple to state and difficult to accept. There is no picture-independent or theory-independent concept of reality. What we call real is always real, according to some model. Let me be very precise about what this means and what it doesn't. It does not mean reality is whatever we want it to be. Our models are severely constrained by observation and internal consistency. You cannot simply decide that gravity repels or that time runs backward on Tuesdays and have a workable model of reality. The universe pushes back against our descriptions with tremendous force. Models that don't fit the data get discarded ruthlessly. But, and this is the crucial insight, when two different models both fit all available data and make identical predictions, there is no fact of the matter about which one is really true. They are equally valid descriptions of reality. Not approximately equally valid. Exactly equally valid. This isn't relativism, it's precision about what truth can be. Consider an electron. Is it a particle or a wave? The answer, strange as it sounds, is both, depending on the experiment. In some arrangements, it behaves like a particle, localized, countable, discrete. In others, it behaves like a wave, spread out, interfering, continuous. Both descriptions are necessary. Neither is complete alone. And the question, but what is it really? That question assumes a really that may not exist. This is already true in established physics. Heisenberg's matrix mechanics and Schrödinger's wave equation looked completely different when first developed, one using matrices, one using differential equations. But they turned out to be mathematically equivalent. Different languages for the same predictions. If you ask which formalism describes what's really happening, you're asking a question without content. They're both true. They're both useful. There's nothing more to say. The implications ripple outward. Every observation, it turns out, is theory-laden. To see the position of an electron, you must trust your detector, which means trusting the physics that predicts how detectors work. To measure the age of the universe, you must assume stellar physics, nuclear physics, and cosmological models are correct. There is no raw, uninterpreted data, no pristine observation untouched by theoretical assumptions. This might sound like a recipe for chaos. If we can never access reality directly, how can we know anything? But we can know a great deal. The criteria for good models are rigorous: predictive accuracy, internal consistency, connection to other successful models, explanatory elegance. These criteria are demanding. Most models fail. Science progresses by discarding what doesn't work and retaining what does. The difference is subtle but profound. We've lost the claim to access reality in itself. We've kept everything that actually mattered: predictive success, explanatory power, the accumulation of knowledge. We've given up only an illusion of certainty we never actually possessed. Think of how you navigate your city. You use a map. The map isn't the territory, it's paper and ink, or pixels on a screen. But if the map gets you where you're going, do you care that it's not really the city? The map is useful because it has a structural correspondence with the territory. Our theories are maps of reality. Very good maps, but maps nonetheless. Now consider, do you ever encounter your city directly, unmediated by any model? Even walking through streets involves visual processing, spatial frameworks, categorical assumptions. You don't see photons, you see colors your brain constructs. You don't touch atoms, you feel the electromagnetic repulsion between electron clouds. Experience is always experience, according to some model. This isn't a problem. It's how experience works. People sometimes resist model-dependent realism because they think it means all models are equally valid. This is absolutely wrong. Most models fail catastrophically. The constraints are severe. Astrology makes predictions. They just happen to be wrong. Flat Earth models fail basic observational test. The universe is enormously discriminating about which models it permits. What model-dependent realism abandons is only this: the idea that when two models both pass every test, one must still be more true because it matches reality in itself. That notion assumes we can compare models to something other than observations and consistency. We cannot. Consider two fish in two differently curved bowls, developing physics that works perfectly within their respective environments. Neither can claim their physics is more real. Both are valid descriptions from within their frameworks. There's no view from outside all possible bowls. There's no framework for comparing frameworks. There's no God's eye view that shows reality as it truly is. We find ourselves in the curious position of successful fish. We can predict everything we observe. Our models are extraordinarily powerful. We've built technologies that would seem magical to our ancestors, and we've done all this without ever accessing reality itself. Only reality, according to our models. Is this a limitation? Perhaps. but it's also liberating. We're not failed gods, unable to reach truths that exist beyond our grasp. We're remarkably successful fish, predicting everything in our bowl with astonishing precision. That should be wonder enough. But here's the question that now presses upon us. Just how strange might valid models get? If we can only know reality through models, and if some very weird models fit the data as well as familiar ones, we must take them seriously. And the holographic principle suggests something extraordinary. Our three-dimensional space might be mathematically equivalent to information on a two-dimensional surface. We might be projections. Black holes are the universe's most extreme objects, places where gravity becomes so intense that not even light escapes, where time and space twist into configurations that defy intuition. For decades, physicists studied them for their gravitational properties, but black holes taught us something unexpected, something that has nothing to do with gravity directly, and everything to do with the nature of space itself. They taught us about information. Consider a simple question. How much information can you fit in a box? The naive answer seems obvious. It depends on the volume. A bigger box holds more stuff, so it should hold more information. This seems so self-evident that no one thought to question it. Then Jacob Bekenstein and others began studying black holes thermodynamically and discovered something strange. A black hole has entropy, a measure of its information content, but that entropy is proportional to the black hole's surface area, not its volume. Specifically, to the area of its event horizon, the spherical boundary beyond which nothing returns. This is backwards from every intuition. A sphere's volume grows faster than its surface area as it gets bigger. If information scaled with volume, a black hole should hold vastly more information as it expands. But it doesn't. Double the radius, quadruple the information, not octuple it, as volume would suggest. This was the first hint that our assumptions about space and information were deeply wrong. The holographic principle generalizes this finding. It proposes that the maximum information that can fit in any region of space is proportional to the region's boundary area, not its volume. The three-dimensional interior is, in a precise mathematical sense, equivalent to information encoded on its two-dimensional surface. The name comes from ordinary holograms, those shimmering images on credit cards and security labels. A hologram encodes three-dimensional information on a two-dimensional surface. Illuminate the surface correctly, and you can reconstruct the 3D image. The holographic principle suggests the universe itself might work similarly. This sounds like metaphor. It isn't. In 1997, the physicist Juan Maldacena demonstrated something remarkable, a precise mathematical equivalence between a theory of gravity in a curved five-dimensional space and a quantum theory without gravity on its four-dimensional boundary. The two theories, completely different in their mathematical language, one containing gravity and extra dimensions, one containing neither, make identical predictions for every possible observation. They are the same theory, written in different languages. This is called the ADS/CFT correspondence, and it has passed every test physicists have devised. It's not speculation. It's where the mathematics leads. The implications are vertiginous. If the boundary description is fundamental, then the interior space is a derived phenomenon, emergent rather than basic. Just as temperature emerges from molecular motion, there's no temperature in a single molecule. Space might emerge from more fundamental information-theoretic processes. The three-dimensional world you experience might not be reality's foundation. It might be a projection. Imagine compressing a movie file. The original video contains what appears to be three-dimensional information unfolding over time, actors moving through rooms, objects receding into distance. But you can encode all of it as a one-dimensional string of ones and zeros. Nothing is lost. Every scene can be reconstructed perfectly. The holographic principle suggests the universe has a similar hidden structure. Everything happening in any volume of space, every particle, every field, every event, can be fully described by information on that region's boundary. The movie of three-dimensional reality is equivalent to data on a two-dimensional surface. Now, you might wonder what this boundary actually is. Is it a wall we could visit? A physical surface at the edge of space? Not quite. The boundary is a feature of the mathematical description, a way of organizing the information content rather than a place you could travel to in ordinary space. This is hard to visualize precisely because our intuitions assume space is fundamental. The holographic principle suggests it isn't. Let me be clear about what I'm claiming and what I'm not. I'm not claiming we definitely live in a holographic universe. The ADS/CFT correspondence applies to a specific type of curved space that doesn't exactly match our universe. Whether our actual cosmos is holographic remains an open question. What I am claiming is this: physics has demonstrated that three-dimensional descriptions and two-dimensional descriptions can be exactly equivalent, not approximately, not metaphorically, but mathematically. The usual assumption that a region's contents can only be described by theories that use that region's full dimensionality is wrong. Fewer dimensions can suffice. And if our 3D world can be equivalent to 2D information, if space itself might be emergent rather than fundamental, then a further question arises naturally. Could that information be a computation? Could we be, in some precise sense, a simulation? The simulation hypothesis proposes that our universe might be a computation running on some substrate we cannot observe, a vast information processing system whose outputs we experience as physical reality. This idea often gets dismissed as science fiction or philosophy gone wrong. But here's what makes it scientifically interesting. Physics cannot rule it out. And that tells us something important about the limits of physics itself. Consider what it would mean for a simulation to be perfect. Such a simulation would reproduce all physical laws exactly. Every quantum effect, every relativistic correction, every thermodynamic fluctuation would unfold precisely as the equations dictate. The simulation wouldn't approximate our physics, it would implement it flawlessly. Could beings inside such a simulation detect that they were simulated? The answer, upon reflection, is no. Any test they devised would be part of the simulation. Any measurement they made would be processed by the simulation's physics. Any anomaly they hoped to find would, by definition, not exist in a perfect simulation. The very concept of testing whether this is a simulation assumes you can compare your world to something outside it, but you cannot. This is not technological limitation, it's logical necessity. If a simulation perfectly implements the laws of physics, it is empirically indistinguishable from base reality, whatever that might mean. No experiment could tell the difference. The question, is this a simulation, would be another malformed question, like asking whether the electron is really a particle. Now, does this mean we probably are in a simulation? Not necessarily. The argument shows that we cannot rule out being simulated, not that we're likely to be. Various probability arguments have been proposed, but they rest on assumptions we can't verify. What matters is what the undecidability reveals. That base reality may be a concept without content. Think about it through model-dependent realism. We've established that we can only know reality through models, and that when two models make identical predictions, both are equally valid. Now add simulation to the mix. Physical universe and perfect simulation of physical universe are two descriptions that make identical predictions by definition. If model-dependent realism is correct, neither description is more true. The simulation hypothesis isn't really a claim about computer programmers in some higher reality, though people often picture it that way. It's a demonstration that the concept of base reality versus derived reality may not survive philosophical scrutiny. Here's a thought experiment. Imagine that tomorrow, by some inconceivable means, you received definitive proof that you're living in a simulation. Never mind how. It's a thought experiment. What would change? Would your morning coffee taste different? Would music lose its power to move you? Would the people you love become less real? Would your projects and hopes suddenly cease to matter? Most people, upon honest reflection, find that the answer is surprisingly little would change. The experiences that constitute your life would remain exactly as they were. Love would still feel like love. Beauty would still stop you in your tracks. Suffering would still hurt. What this reveals is remarkable. Your actual values never depended on metaphysical certainty about base reality. You were always living in model-dependent reality. You just didn't notice. The simulation hypothesis, properly understood, isn't an existential threat. It's a particularly vivid way of seeing what model-dependent realism already implies. That asking what reality is in itself, apart from all frameworks and descriptions, may be asking a question without an answer. Some take this as disturbing. I find it clarifying. We've been asking, what is reality really? As though there must be an answer, independent of our models. We've been assuming that somewhere beneath all descriptions lies raw, uninterpreted existence, and that truth means matching that substratum. But we have no access to such a substratum. We've never had such access. Every attempt to describe reality in itself is just another description. If we might be projections, or holograms, or simulations, and if this changes nothing about experience, meaning, or value, then perhaps base reality was never what gave life meaning in the first place. The universe, it seems, doesn't care about our metaphysical preferences. It does what the equations say, and the equations say that some questions we desperately want to answer may have no answers to give. There's a certain cosmic comedy in our situation. We are creatures who evolved to find food and avoid predators, who developed consciousness as a survival advantage, who eventually built particle colliders and space telescopes, and who have now discovered that the deepest questions we can ask may dissolve rather than being answered. But we have followed the argument where it leads. From the coffee cup that may not exist when unobserved, through the quantum weirdness that shows observation matters fundamentally, past the goldfish in curved bowls who can never escape their frameworks, into holographic boundaries where 3 dimensions equal 2, and finally to the recognition that base reality may be a philosophical phantom. Throughout this journey, we've treated one thing as constant: the observer. You, the one doing the questioning, the mind seeking answers. But if reality is model-dependent, if we are our models, then what about the self? What about the observer? Can the modeler escape the logic that applies to everything else? As we shall see, the answer is no. And this leads us somewhere unexpected. We have followed model-dependent realism through strange territory. We've seen that reality may not exist independently of observation, that we are all goldfish in curved bowls, unable to escape our frameworks, that our three-dimensional world might be equivalent to two-dimensional information, that the very notion of base reality may be philosophically empty. Throughout this journey, one thing has remained constant. You, the observer, the mind asking questions. But here's the question we must now confront. If reality is model-dependent, can the observer escape this logic? The answer, as we shall see, is no. And this leads us somewhere unexpected, not to existential crisis, but to a deeper consistency. Consider how you know yourself. You look in a mirror. What do you see? A reflection, one model of your appearance, from one angle, at one moment. The image is reversed left to right. It captures only your surface. It shows you only how you appear when you're consciously looking at yourself, which may be different from how you appear the rest of the time. You might add photographs to your self-knowledge. Different angles, different moments, different lighting. Brain scans showing neural activity. Psychological profiles describing your tendencies. Medical records documenting your biology. Each source gives you more data. But notice, each is still a model, a representation from some perspective. Where is the real you, independent of all perspectives? This isn't about inadequate technology. Even if you had perfect information from every possible angle, you would have only an infinitely detailed model, not you as you really are, independent of any description. The notion of a self that exists prior to all representation turns out to be as problematic as the notion of reality prior to all models. You are model-dependent too. Your sense of being a continuous self, persisting through time, is itself a model, a useful integration of memories, sensations, and anticipations. It works beautifully for everyday purposes. It predicts your behavior reasonably well. It enables planning and social coordination. But it is not the only possible description of the same underlying processes. You could be described as a momentary configuration of matter, a snapshot that bears resemblance to previous snapshots but makes no metaphysical claim to identity across time. You could be described as a pattern in computational substrate if the holographic principle is correct. You could be described as information on a cosmic boundary. Each description fits the available data. The question, who am I really, turns out to be as problematic as, what is reality really? Both assume a ground truth independent of all frameworks. Both may be asking for something that doesn't exist. This might sound distressing, but let me offer a different perspective. Quantum mechanics taught us that the observer is part of the system. The measurement apparatus isn't a passive window onto reality. It participates in determining outcomes. There is no neutral position from which to observe the universe untainted by the observation itself. The same logic applies to self-observation. You cannot step outside yourself to see yourself as you really are. Every act of introspection involves frameworks, assumptions, and perspectives. You are always viewing yourself from somewhere. There is no view from nowhere. Consider memory. Your sense of continuous identity relies heavily on memory. You remember being yourself yesterday, last year, in childhood. But memory is not a recording, it's a reconstruction. Each time you remember, you rebuild the event from partial data, shaped by current expectations, emotional state, and narrative needs. Studies show that memories change with each recall. You don't replay stored files. You reimagine the past. This means your past self is a model constructed now, not a recording of what actually was. You remember yourself into existence moment by moment. Or consider the ship of Theseus problem applied to you. Every atom in your body is replaced over a period of roughly 7 years. The cells in your brain, the supposed seat of your identity, turn over throughout your life. The matter that constituted you as a child is long gone, scattered across the planet, incorporated into other organisms, breathed out as carbon dioxide. Are you the same person you were at age 5? The question assumes there's a fact of the matter about sameness independent of how we define it. But sameness is a concept we apply, not a property we discover. Different definitions give different answers. In meditation, practitioners sometimes report experiences where the sense of self, the feeling of being a distinct I, observing experience, fades away while awareness continues. Consciousness without a center. If the self can apparently vanish while experience persists, the self is something consciousness constructs, not its necessary foundation. You don't need to meditate to grasp the point. Notice how your sense of self shifts across context. With old friends, you are one person. Certain jokes land, certain topics arise, certain patterns of interaction feel natural. At work, you are someone subtly different. Different vocabulary, different posture, different concerns. Alone, you are someone else again. Which is the real you? The question assumes a core self behind the variations. But perhaps the self is nothing but the variations, patterns that cohere well enough to enable prediction and coordination, without requiring a hidden essence that really exists beneath them. This needn't be disturbing. Your self-model works. It enables you to navigate life, make decisions, maintain relationships, pursue projects. The fact that it's a model doesn't make it less functional. It just clarifies what kind of thing it is. And here's the consistency I mentioned. If model-dependent realism is true of the external world, it must be true of the worldly creature asking about it. You are part of the world. If the world is model-dependent, you are model-dependent. The observer cannot stand outside the logic that applies to everything else. Some find this troubling. But surely I exist. Descartes said, I think, therefore I am. Yes, something is happening. Experience is occurring. But what that something is, what kind of entity is having the experience, whether it persists over time, where its boundaries lie, these are questions answered differently by different models. The existence of experience doesn't establish the nature of the experiencer. Descartes proved that something thinks. He didn't prove what that something is. We've seen that the self is model-dependent. But this raises an urgent practical question. How do we live when both reality and self are models? If every foundation has become provisional, where is solid ground? The answer, as we shall see, is that we've been standing on solid ground all along. We just misunderstood what solidity means. There is an old story about a man who searches for his keys under a street lamp. A friend asks, "Where did you lose them?" "Over there, in the dark," he replies. "Then why search here?" "Because here the light is better." We have been like this man, searching for metaphysical certainty because the light seemed better there, because certainty felt like the only acceptable foundation for knowledge, action, and meaning. But the keys were never there. They were always somewhere else. The journey we've taken through quantum observation, model-dependent realism, holography, simulation, and the model-dependent self might seem to end in a void. If we can't access reality in itself, if even the self is a construction, what's left? Where do we stand? But here's what I want to suggest. We've lost nothing real. We've lost only an illusion of certainty we never actually possessed. Consider how you learned to ride a bicycle. There was no moment when you achieved perfect, certain knowledge of how to balance. You wobbled, fell, adjusted, wobbled less. Eventually, you developed a feel, a model, implemented in muscle memory and neural circuits that worked well enough. You stopped falling, but you never acquired a guarantee you wouldn't fall. The ground might be slippery, the tire might burst, you might sneeze at the wrong moment. You ride anyway. This is how all action works. We act from models that work well enough, without metaphysical guarantees. We always have. Model-dependent realism doesn't introduce uncertainty into a previously certain world. It describes the uncertainty that was always there, hidden by illusions of foundational knowledge. Think about your daily decisions. You don't wait for complete information before acting. You don't pause to verify that the external world exists before eating breakfast. You don't confirm the fundamental nature of causation before flipping a light switch. You act on models that work, update when they fail, and rarely worry about whether your framework is ultimately true. This isn't sloppy thinking. It's how intelligent action operates. Model-dependent realism doesn't change your practice. It describes what your practice has always been. The question is whether this practical orientation can extend to the deepest questions, questions about reality, truth, meaning, and self. Can we live without metaphysical foundations? I believe we can. In fact, I believe we always have. We've just pretended otherwise. Consider meaning. What gives your life meaning? Perhaps it's relationships, people you love, communities you belong to. Perhaps it's creative work, things you build, ideas you develop. Perhaps it's curiosity itself, the joy of understanding, the thrill of discovery. Perhaps it's some combination, shifting emphasis over time. Now ask, do any of these require metaphysical certainty about base reality? Does loving your family require knowing whether the universe is a simulation? Does creative satisfaction require certainty about the ultimate nature of matter? Does curiosity about the cosmos depend on proving that space is fundamental rather than emergent? The honest answer, I think, is no. The things that actually constitute meaning operate at a different level than metaphysical foundations. They are patterns within experience, patterns that persist whether experience is grounded in base reality or not. This is not resignation, it's recognition. We sought a view from nowhere, a framework outside all frameworks, a truth independent of all descriptions. We didn't find it, not because we failed, but because it doesn't exist. What we found instead is that the views from somewhere are all there is, and views from somewhere are enough. Consider science itself. Science proceeds without metaphysical certainty. Newton didn't know what gravity really was. He famously refused to feign hypotheses about its ultimate nature. But he could describe what it did, predict where planets would be, calculate the tides. His model worked. That was enough. Einstein replaced Newton, not by discovering what gravity really is, but by providing a better model, one that predicted phenomena Newton's model couldn't explain. Einstein's model works better. That's all better can mean in this context. Science doesn't converge on reality in itself. It converges on models of increasing predictive power and explanatory elegance. These are remarkable achievements. They don't require, and couldn't receive, certification from beyond all frameworks. The same pattern extends to ethics, to relationships, to the pursuit of happiness. We navigate these domains with provisional models, updating when experience contradicts expectation, building knowledge that works without claiming to be ultimate. Some worry that without foundations, anything goes, that moral relativism or epistemological chaos must follow. But this worry is misplaced. Models are severely constrained by experience and internal consistency. The fact that there's no view from nowhere doesn't mean all views are equally valid. Most views are wrong. They fail to predict. They contradict themselves. They conflict with evidence. The universe discriminates ruthlessly among models. What we've lost is only the claim to access reality in itself. What we keep is everything we actually use, rigorous criteria for evaluating models, accumulated knowledge, predictive success, explanatory power. Nothing has been taken away. There is even a kind of freedom in this recognition. Holding models lightly allows updating them when evidence conflicts. Certainty is the enemy of growth. The person who knows they're riding a bicycle without guarantees pays attention to the road. The person who believes they have achieved perfect balance is about to be surprised. We've integrated model-dependent realism into something livable, but something seems missing. Wonder. If we're just navigating models, where's the awe? As we shall see, the awe isn't diminished. It's transformed. We have travelled far from that coffee cup on the table. We've seen that reality may not exist independently of observation, that asking what the cup is doing when no one looks may be like asking what lies north of the North Pole. We've learned that all our knowledge comes through models, and that when models make identical predictions, neither is more true. We've confronted the possibility that three-dimensional space is equivalent to two-dimensional information, that the question of whether we're simulated may be malformed, that even the self is a construction. It might seem that we've emptied the world of substance, reduced everything to mere appearances, left ourselves with nothing but shadows of shadows. But here's where we turn. Look at your hand. It is made of atoms, hydrogen, carbon, oxygen, nitrogen, and traces of heavier elements. The hydrogen formed in the first minutes after the Big Bang, when the universe was a hot plasma just beginning to cool. The carbon, oxygen, and nitrogen were forged much later, in the nuclear furnaces at the cores of massive stars, stars that burned for millions of years, then exploded as supernovae, scattering their processed elements across space. Some of those scattered atoms drifted into a cloud of gas that collapsed to form our solar system. They accreted into a rocky planet, third from a medium-sized yellow star. Over billions of years, through processes we're still uncovering, those atoms organized into molecules, the molecules into cells, the cells into organisms of increasing complexity. And now, those atoms are looking at themselves. When you lift your hand, you are witnessing the universe moving itself through patterns of matter that have become self-aware. The carbon in your muscles was made inside a star. The neurons asking about neurons were assembled from stellar ash. You are not merely a creature living in the universe. You are the universe, organized into a form capable of asking about itself. This is not poetry. It is direct description of what the physics implies. We are star stuff that has become conscious of being star stuff. Consider music. Without ears and minds, sound waves are just pressure fluctuations in air, compressions and rarefactions propagating at 300 meters per second. The fluctuations are real, but music is not in the fluctuations. Music exists only in the hearing, in the relationship between sound waves and auditory systems sophisticated enough to process them? Is music less real because it's relational? Or is this what reality always was? Not things in themselves, but relationships between phenomena and the systems that perceive them? We are like ears that evolved in a universe of pressure waves and discovered music. The music was always possible in the waves. We are its realization. The same logic applies to meaning, beauty, wonder. These are not decorations we paint onto a meaningless cosmos. They are not illusions distracting us from cold, mechanical truth. They are the cosmos becoming meaningful, beautiful, wonder-filled through us. If reality is model-dependent, and we are the modelers, then our inquiry is reality knowing itself. Our questions are the universe's questions. Our wonder is the universe wondering. This is where model-dependent realism leads if you follow it honestly. Not to nihilism, not to the conclusion that nothing matters because everything is just models, but to the recognition that mattering is something minds do, that meaning is something conscious beings create, and that we are the place in the universe where these things happen. The universe has no meaning apart from creatures who find meaning. We are those creatures. The universe has no beauty apart from minds that perceive beauty. We are those minds. The universe has no wonder apart from consciousnesses that feel wonder. We are those consciousnesses. This is not diminishment. It is elevation. We sought truth out there, independent of all observers. We didn't find it, but we found something else. We are not outside reality looking in. We are reality looking at itself. There is an old philosophical puzzle. If a tree falls in a forest and no one hears it, does it make a sound? The answer depends on how you define sound. If sound means pressure waves, yes. If sound means auditory experience, no. Experience requires experiences. But the deeper answer is that the question reveals something about questions. What is X really? Independent of all observers, may be the wrong kind of question. Reality may not be the kind of thing that can be independent of observation. Not because observers create reality through wishful thinking, but because reality is relational all the way down. Stand outside on a clear night. Look at the stars. The light hitting your eyes left those stars years, decades, centuries, millennia ago. Depending on how far away they are, you are seeing the past. But more than that, those stars, and stars like them, made the atoms in your eyes. You are not merely looking at stars. You are stars that have become conscious, looking back at the kind of furnace that forged you. The carbon in your retinas was cooked in a stellar core. The iron in your blood was synthesized in a supernova. The calcium in your bones, the phosphorus in your DNA, the oxygen you're breathing right now, all of it passed through nuclear fire before condensing into this planet, into you. You are the universe's way of seeing itself. This is not mysticism, it is physics taken seriously. And here's what survives model-dependent realism. This wonder. Not wonder. At a universe that exists independently, we cannot access such a thing. Wonder at the fact that we exist at all. Wonder that consciousness has emerged. Wonder that matter has organized itself into creatures who ask questions about matter. The fact that we can understand the cosmos at all is remarkable. The universe is under no obligation to be comprehensible. It could have been chaos, random, lawless, forever beyond the reach of mind. Instead, we find patterns, regularities, laws that fit in our heads. We are just an advanced breed of monkeys on a minor planet of a very average star. But we can understand the universe. That makes us something very special. We began asking, what is reality, really? and found the question dissolves. What remains is something more remarkable. We are the question being asked. We return now to where we began. The coffee cup sits on the table, ceramic, slightly cooled, waiting. Or is it waiting? We've seen that waiting presupposes observer-independent existence, a cup persisting in a definite state whether or not anyone observes. We've seen that this assumption, so obvious to common sense, finds no support in fundamental physics. We've seen that asking what the cup is really doing when unobserved may be like asking what lies north of the North Pole, a question whose grammar suggests it should have an answer, while the physics suggests otherwise. What then do we say about the cup now? Here is what I would say. The cup is real, but real means something different than we thought. The cup exists, but its existence is not separable from the models through which existence is known. The cup has properties, but those properties are defined relative to measurement procedures and theoretical frameworks. The cup is there, but there is a concept within our spatial model, not a feature of reality in itself. This sounds like we've diminished the cup, but we haven't. The coffee is still hot. The ceramic still feels solid under your fingers. You can still drink from it. Nothing practical has changed. What's changed is our understanding of what it means for the cup to exist, not independent of all observers, complete in itself, indifferent to inquiry, but real nonetheless, real within the frameworks through which reality is known, which are the only frameworks there are. And what about you, looking at the cup? We've seen that you too are model-dependent. Your sense of continuous selfhood is a construction, useful, predictive, but not a direct apprehension of your essential nature. There may be no essential nature to apprehend. Who am I really? May be the same kind of malformed question as what is the cup really doing when unobserved. But you are real too. Experience is happening. Consciousness is inquiring. Something is looking at the cup and wondering about it. That something is part of reality. The wondering is part of reality. The inquiry is not separate from what's being inquired about. Here is the deepest insight I can offer. Your question, what is real, is itself a real event. Neurons are firing. Consciousness is engaging. The universe is attending to itself. The question is not outside reality, seeking to understand what's inside. The question is inside reality, part of its ongoing self-disclosure. When you ask, what is reality? The universe is asking about itself, through you. This is what remains when the traditional conception of truth dissolves. We sought truth as correspondence, our descriptions matching reality in itself. We found that we cannot access reality in itself, but we found something else, truth as participation. We don't discover pre-existing truth. We are truth discovering itself. The question is the answer, not because answers don't matter, they do. Models are severely constrained by evidence. Science progresses. Knowledge accumulates. Some descriptions work better than others. But beneath all particular answers lies this more fundamental truth. We are the universe questioning itself. Every question we pose is the cosmos attending to its own nature. Every insight we reach is reality, becoming more transparent to itself. There is a tendency to hear this and think it's fuzzy mysticism, nice-sounding words without content. But it follows directly from the physics. If reality is model-dependent, and we are the modelers, then our modeling is part of reality. If the universe includes conscious beings who inquire into the universe, then inquiry is a cosmic phenomenon. If meaning exists only for creatures who find meaning, and we are such creatures, then we are where meaning lives. This is not wishful thinking, it's logical consistency. Now let us complete the arc. We began with naive realism, the assumption that reality exists independently, that things are there, whether we observe them or not. That truth means matching our descriptions to this independent existence. This assumption is so natural, so practical, so woven into our language that questioning it feels almost mad. But question it we did. The double-slit experiment forced us to confront observation's role in determining outcomes. Model-dependent realism showed us that we can only know reality through models, and that when models make identical predictions, neither is more true. The holographic principle suggested that 3 dimensions might equal 2. The simulation hypothesis revealed that base reality may be a concept without content. The model-dependent self showed that even the observer is constructed, and now, at the end, we find that what seemed like loss is actually recognition. We have not discovered that nothing is real. We have discovered what real can mean. We have not found that truth is impossible. We have found what truth can be. We have not concluded that wonder is an illusion. We have found where wonder lives, in us, as the universe wondering at itself. The coffee cup sits on the table. It is the universe presenting a cup. You are the universe observing it. The presentation and the observation are both real, not independent of each other, but constituting each other, aspects of one process that has no outside. There is no view from nowhere. There never was. Every view is from somewhere, and our somewhere, this pale blue dot, these evolved brains, these questioning minds, is not a limitation, but a gift. We are not strangers seeking admission to a pre-existing truth, begging the cosmos to let us in on its secrets. We are the cosmos becoming secret to itself. We are truth happening. What then should we do? Keep asking. The question, what is real, may dissolve into model-dependent realism, but the questioning itself is valuable, not because it leads to answers independent of frameworks, but because questioning is how consciousness engages with existence. Your curiosity is not in vain because it lacks final answers. Your curiosity is the universe being curious. That is its own reward. Look at the stars tonight. Ask what they are. Recognize that the asking is part of what they are. The atoms in your body were forged in stellar cores. The consciousness asking about atoms is those atoms, arranged into patterns capable of inquiry. You are looking at your origins. They are looking back. This is not metaphor. This is not poetry, though it contains poetry. This is direct description of what we are and where we came from. I cannot tell you what exists in itself, apart from all observation and description. No one can. Not because the question is too hard, but because it may be malformed. What I can tell you is what remains when the question dissolves. Consciousness that wanders, models that work, beauty that moves us, love that matters. These are not consolation prizes for failing to reach ultimate truth. These are what there is. These are what there was ever going to be. We sought a view from nowhere and found we were somewhere all along. We sought truth outside ourselves and found we were inside truth. The universe has no meaning apart from creatures who find meaning. We are those creatures. The universe has no wonder apart from minds that wander. We are those minds. Look up at the stars. They are looking back, not metaphorically, not poetically. The looking is real. We are not strangers seeking admission to a pre-existing truth. We are truth happening.